Hello, everyone, and welcome back to this episode of Machine Learning at Lunch. Today we have Giacomo that is talking about geometric representation learning for document image rectification. And this is, I think, a novel architecture or something like that to obtain a rectification of images of documents, as the title says. And Giacomo, you can go on and tell us more about it.
Yeah, so indeed, well, the title is not easy to read, but I think the content is pretty straightforward in general, and actually it's pretty cool. And I thought about this paper. I mean, it's a recent paper, as you said, and I think it's pretty interesting that um, well, I will explain in a second, but essentially, we have to deal quite often with documents that are not like properly photographed for any reason. So because of light, or the paper is not completely flat, but there is some sort of deformation or stuff like that. And if we take these pictures with our phone, then in general, some sort of rectification, as the title says, is needed. So very quickly, the idea is to think about images of documents taken with our phones. Now we have many tools, like, I don't know, I have on my phone the Adobe Scan, I think it's called, or something like that. So you take the picture of your document, let's say, like a letter or something like that, and then it will act as a sort of scanner, so it will put it in black and white, and then also rectify it a little bit. And this is sort of a sort of novel implementation, but there are some other more traditional ways to rectify a document. So um, there are essentially two rectification methods that are reported in the paper, and the first one is that you try and reconstruct the sort of the 3D model of your um, of your image, or the document in your image. But in fact, this one might be based on some other external hardware that will grant you like the possibility of taking the picture, elaborating it, and so on and so forth. And on the other hand, sometimes people tend to use multiple images, meaning that as you do also with advanced deep learning techniques, essentially you don't take a single picture of your document, but more pictures from different angles or stuff like that, and that at some point you would be able to uh, reconstruct, because of this, let's call it stereographic image, the ground truth. So what was the document supposed to be like if it were like flat on your table? And as I was saying, more recently there have been some deep learning techniques employed to perform this rectification. And as you can guess, the presence of external hardware or the multiple images, they are inconvenient, because most of the time we take pictures with our phones, so we don't really want to take more pictures from different angles or have any other hardware attached to our phone, because that's just not the way you want to take your picture. So you want to be quick, and get it, work right off the box. And so these guys are proposing a different solution. So these guys are proposing a deep learning technique, and the idea behind this technique is that, in fact, the basic ingredient of your document, assuming this one is a text document, of course, is that there should be some text lines, and uh, these text lines actually um, are pretty constrained, in the sense that we read the text from left to right and we move horizontally. I mean, if we had another language, maybe Japanese or something, we might move vertically, but in some sense there is a preferred direction. And so this is actually a pretty strong geometric constraint for the reconstruction. And so these guys are proposing a new architecture, which is sort of complicated, if you like, and I will explain it in more detail in a different section. But for the time being, just keep in mind that it's composed of a structure encoder, text line extractor, and a rectification decoder. And so, well, neglecting all these fancy words, the idea is very simple. So, yeah, what you want to do eventually is just compute the displacement, meaning that you start from your image and you select, let's say, a particular pixel, and this pixel is identified by a tuple in the Python language. So if you like, two coordinates that here we are calling I and j, and this is in the original picture. And then you want to find essentially two rectification function, this f and g, that will take the input pixel along the x-axis, let's say, and map it um, to the corresponding pixel in the rectified document, and a similar thing will happen for the y-axis. So this is the basic idea. I don't know if you have if you have any question up to this point. I will dig a little bit deeper in a second, but
Yes, yes. I'll wait you to dig deeper, and then I'll ask questions.
okay. Um, so well, maybe I can start from this one. So this one is essentially the picture of what is going on here, and then I will explain a little bit. So well, the idea just is just to start from this document here. So you see we have some distortion in the document. So it's not even, I mean, it's not flat, it's not even straight. I mean, it's taken from a particular angle. There is some background, and what we want to obtain eventually is this document here rectified on the right. Um, and so what these guys actually do is, first they want to extract the foreground, or if you want, they want to remove the background in this case. Okay, and this is a sort of pre-processing technique. And then they want to use a transformer and a convolutional neural network, and then they want to sort of fuse the result of both networks, and this will be used at the end precisely to extract the rectified document. And the idea for this is actually very simple. Um, so the idea here is that well, of course you want to remove the background for obvious reasons, uh, but in fact, since we have a document, so this document has a sort of rigid structure, it means that parts in the distorted paper, they are not independent, but they are related with one another. So the idea of the transformer here is just to use the self-attention mechanism uh, to capture the long distance features, feature dependencies in your document. Okay, so in some sense there is some recurring structure, okay, in the document, and you want to precisely leverage the power of transformers to encapsulate this dependence. And um,
Sorry, I have a question. Long distance
yeah,
here is actual physical distance, so a point in the upper left and a point bottom right. So they are distant, and we are trying to capture the dependency between these two
yeah,
points, or something like
yeah.
that.
Yeah, essentially, yeah. So we're not talking really about the dependency in the like in any sort of NLP kind of thing. So it's really some geometric dependence and geometric distance, if you like. And and this is a sort of long distance behavior, okay? Or yeah, physicists would call it like an IR thing. And then sorry about this, the tour in physics. And then there is this other thing about the convolution is that actually, pixel belonging to the same text line, they might have some, well, essentially we say that two pixels belong to the same text line, judging from the local behavior. Okay, so we are not interested in the long distance, but we are interested in the short distance. So the idea is that in this case for a physicist it would be a UV dependence, but uh, this is precisely why we use convolution, because we want to extract some information from the local, let's say, behavior of our text line. And so we are using a transformer and using a convolutional neural network. We are actually taking the best of both worlds, and then we are fusing them together in the final answer. And this, I think, I already talked about this for a little while, but essentially what we already said, in the sense that the text line should be the main texture of our document. And again, it could be vertical or horizontal, depending, for instance, on the language or particular formatting that you have your paper. um, and so in some sense they say, the distribution of the text lines in the form document actually is related to the deformation of the document, right? Because we know that they have a rigid structure in general. So by and yeah, through the analysis of the deformation, we should be able to reconstruct the deformation itself. Um, and that's pretty much the idea. So again, this is I mean, it's not a super simple
Mhm.
architecture, but it's actually very effective. Apparently, I haven't tested it myself, but um, it should be, in the sense that they report the results on a number of data sets, including, like, I think a pretty new one that I can't remember the exact name, but it was a new one, and it was like, uh, developed precisely for gauging, like, performances of different algorithms for document rectification. And apparently they are creating a new state of the art um, network or algorithm for this sort of task. And so I thought it would be, pretty interesting from our side, since we have different projects that might relate to this.
Yes,
um,
I have. I'm just wondering about the computational complexity, as always, because here we have a pretty complex structure with a transformer, a CNN. So if we are going to use this on a mobile phone, on a smartphone, we will.
um, Yeah,
I
so
don't.
I think that they were saying, yeah, no, it's a good point, actually. Um, so if I remember correctly, in the training phase, it's not too much of a big deal, in the sense that they were using, I think, maybe a couple GPU. Well, I can't remember. I think a couple of 2080. I think so. I mean, it's a good GPU. It's not anything like an 8000 or something. So still something that you can probably buy. Of course, not something that you could use on a phone, at least for the training phase. But in the training phase, I think it was not. I think they let it run for 40 epochs, 50 epochs, something like that. So yeah, not too much, even though they do not say precisely how many documents they were
Yes, but
processing.
for the training
Uh,
phase, we are not really interested because we could train
yeah,
on
exactly. And yeah, and for the inference phase, which was your question, I guess, I don't think they reported anything specific. I remember that they were saying that they were looking at the um, yeah, performance, let's say, from a computational point of view, and they were pretty good. And I think that's pretty much what they said. I don't think they went too much in detail about that. So I'm afraid I can't tell you much more
a
than this
program.
at the
No,
moment.
this could also be an
uh
AI or something. So you send your picture to the internet and
yeah.
then process it and you get the result. But it would be interesting also to have this application directly on your mobile,
I,
like we have on our iPhone. It's not able to do the rectification if the document is as in this picture, but maybe in the future.
yeah. Yeah, yeah, I don't think they benchmark it on any mobile phone kind of thing. So yeah, I don't think I have an actual answer to your question, but yes, I mean, I think if you develop anything like this, you definitely want to assess, the actual performances on mobile devices, or stuff like those, because that's what this algorithm is supposed to be working on.
Mhm.
It's not supposed to be running on some huge cloud computer, or whatever. So yeah, thanks for asking. I don't have a definite answer about that.
No problem. And I think that's it. If you don't have
Yeah,
anything
no, I
to
don't
add,
have. Yeah, no, I don't have anything else to add. And thanks for the questions, by the way.
thank you for presenting. Thank you, Giacomo, and bye bye to everyone.